Here the statement of the problem is, when a light ray enters from a rarer medium to a denser medium, comment on its speed and the wavelength, right? You have to figure out which of the quantity in speed and wavelength decreases and which of the quantity increases, right? Or you have to actually figure out the change in the speed and wavelength, right? Now, if we look into the diagram, let's say this is a light ray which is entering from a rarer medium to a denser medium, right? Rarer medium means this. This is a rarer medium. And let's say this slab is a denser medium, optically denser medium, right? You must have heard or you must have read the definition of optically denser medium. We'll discuss it. So, before we go into the detail, what you need to understand is there are three characteristic things which are associated. There are many more things, but for our problem, we'll take out three characteristic things related to a wavelength, related to a wave. Light ray is a wave, right? So there are three things. What is that? V, that is the speed. If we talk about the speed, V is the speed of wave propagation, that means the speed of the light ray. Frequency F, and the wavelength lambda. Now whenever the medium changes, see, the light ray is going from rarer to denser medium, so the medium is changing. Whenever the medium changes, the frequency of the wave remains constant. Frequency of the wave is such a property that is independent of medium. Why so? Because frequency depends on the source. So if the source is fixed and you talk about a particular light ray emitted from a source, from a particular source, then frequency will be constant. In whatever medium it goes with the same frequency, right? So what are the two things remaining? The speed and the wavelength. Okay. Now, there is one more thing we know for the medium, defined as refractive index. Refractive index of a medium is defined as C by V. So, C is the speed of the light ray in the vacuum, right? And V is the speed of the light ray in the particular medium whose refractive index is N. Correct? Now, if a medium is optically denser, that means its refractive index is more. Optically denser medium means a medium which is having higher refractive index. Now, higher the refractive index and C being the constant, the speed of the light ray should decrease. So, as the light ray enters from a rarer medium to a denser medium, its speed decreases, right? Because its refractive index, because the refractive index of the medium is increasing, the speed will decrease from this formula, right? Now, there is one more relation in between V, F and lambda. What is that relation? That relation is this. V is equal to F lambda. You all have studied this in detail, right? Now, if frequency remains constant, because it depends on the source. So if frequency of the light ray of the wave, it remains constant and speed is decreasing, then from V is equal to F lambda, lambda must also decrease, right? So if V decreases, lambda must also decrease. So as the light ray enters from a rarer medium to a denser medium, both its speed and the wavelength should decrease. Now this is the answer. And let's look into the options. Option D will be the correct option in this case. In this problem, the exact same concept is being used as the previous problem. The only difference in this problem is that in this problem, some data is given. So looking into the data, you have to deduct the correct result, right? So the statement is a red color light of wavelength 760 nanometer is observed to pass from air to an unknown medium. If the wavelength of the light is in unknown medium becomes 570 nanometer, the unknown medium is, and you have to comment on the medium being optically denser or optically rarer, or it is having same refractive index as of the previous medium, or you have insufficient data for the calculation of this, right? Okay, so now if we look into the solution part, we'll do exact the same thing. We'll consider a light ray which is entering from one medium to other medium. This time we do not know about the medium, which medium is being denser and which medium is being rarer. We have to get that, right? Okay, so let's say this is medium 1 and this is medium 2, right? Okay, now what information you have been given about the wavelength, so you can see the wavelength is decreasing from medium 1 to medium 2. When the light ray is entering, the wavelength of it is decreasing. Now you know the three characteristic things, V, F, lambda. They are related as V is equal to F lambda, right? And what you have been given, that lambda is decreasing. If you go from medium 1 to medium 2, for the light ray, the wavelength is decreasing. Now decreasing wavelength and frequency being constant. Again, why frequency is constant? Because frequency is the property of source. So for a particular light ray, in whatever medium it is, the frequency is a constant, right? So frequency being constant, lambda is decreasing. So for the transition from medium 1 to medium 2, the speed should also decrease, right? If lambda decreases from this equation, then this equation says V will also decrease, right? The speed will also decrease. And now you know one thing, that refractive index of a medium is defined as C by V, where C is a constant and that is equal to the speed of the light ray in the vacuum, right? So if V is decreasing for the transition from medium 1 to medium 2, if V decreases, then from N is equal to C by V, N should increase. That means the medium 2 is having a higher refractive index, and the medium having higher refractive index is optically denser. So that is why medium 2 will be optically denser medium as the given data. If you look into the given data, you can conclude that the medium 2 is an optically denser medium because it is having a higher refractive index. So the correct answer is optically denser. Let's look into the options. Option A will be the correct option in this case. Here the statement is, the angle of incidence in medium 1 is 60 degrees and the angle of refraction in medium 2 is 30 degrees. Find 1 mu 2. So this problem is about understanding the notation and then knowing the basic law, which we know as Snell's law, right? So notation means what? Means this 1 mu 2. Now you know that for a medium n and mu, these are the two common letters used to show the refractive index. So whether it is n or mu, by default we take it as refractive index of the medium if something else is not related or not given to be related to these signs. If they are directly given to you and nothing is being said about them, then n or mu in these problems will be taken as refractive index. Correct? Both n or mu. Anything can be given as refractive index, right? Here the letter mu is used. That means it is talking something about refractive index of the medium. Now what is this notation 1 mu 2? That is relative refractive index. 1 mu 2, it commonly means mu 2 divided by mu 1, which we define as relative refractive index of medium 2 with respect to medium 1. So if this notation is being used 1 mu 2, that's mu 2 by mu 1, and that we know as relative refractive index. Correct? Now these mediums are given to you. What is happening? A light ray is coming from medium 1 and it is entering into medium 2 with I, that is angle of incidence, and the R, which is angle of refraction, that is given to you, right? What is incidence, angle of incidence? Incident ray and the normal, that the angle between them is called angle of incidence, right? And then at the point of incidence, if you see the refracted ray and the normal, the angle between them is called as R, that is that is angle of refraction, right? Okay, you have to figure out with the help of the given data mu 2 by mu 1. Let's say this is having mu 1 and let's say this is having mu 2. What you need to figure out is mu 2 by mu 1, right? Let's look into the detail of the figure. This is what the figure is. Incident ray making an angle I is equal to 60 degrees and R is equal to 30 degrees. Medium 1 having refractive index mu 1 Medium 2 having refractive index mu 2, right? What you need to figure out is mu 2 by mu 1. Now, applying Snell's law. What does Snell's law says? For a refraction on the phase boundary in between two mediums, this is medium 1, the entire above thing is medium 1, and the entire down thing, right, is medium 2. So at the interface, if a refraction is taking place, right, Snell's law says mu 1 sine I is equal to mu 2 sine R. This we know as, or we study as, Snell's law. Now, mu 1 sine I is equal to mu 2 sine R. Okay, sir, we have to use this. Do we know I and R? Yes, sir, we know. Then, can you figure out mu 2 by mu 1? Yes, we can, right? How so? Okay, mu 2 by mu 1 will be given as sine I by sine R. Now, everyone knows what sine 30 and sine 60 is, right? So, the answer is in front of you. Mu 2 by mu 1 is equal to sine of I, which is 60 degrees, divided by sine of R, which is 30 degrees. Mu 2 by mu 1 will be equal to, let's look into it, sine 60 is root 3 by 2, divided by sine 30, that's 1 by 2. Now, this 2 gets cancelled. And what you are remaining with, or what you left with, is root 3. So, 1 mu 2 will be given as root 3. The correct option for this problem will be option C. This is a very conceptual problem. A very basic and conceptual system is given in this problem, which is often asked in the examination. Like the problems related to these type of arrangements are often asked in the examination. In whatever examination you give, either NEET or JEE, in both of the examinations, this is one of the relevant systems to study. So the statement is, in the figure shown below, the angle made by the light ray with a normal in the medium of refractive index root 2 will be. Okay, there are 4 options given to you in terms of angles, of course, because you have to figure out some angle. Now, if you look into the system, what is the arrangement? See, every system is parallel to each other. So like there are 1, 2, 3, 4, 5. 5 systems, and all of them are arranged parallelly. So this is a system of parallel slabs, you can say, right? And for the system of parallel slabs, if you see and you consider a light ray which is entering like this, right, making an angle initially I1, and then it is making an angle of refraction in the second medium as R2, then in the next medium is R3, the angle of refraction, then in the next medium it is R4, and then let's say it is moving out with R5, even R5. So first of all, I'm asking you, are the slabs parallelly arranged? Answer is yes. So whenever the slabs are parallelly arranged, please focus. Whenever the slabs are parallelly arranged, you can apply Snell's law in between any two mediums. What do you mean, sir? I'm confused. Okay, wait. What I say is, what you know is the value of I1, and what you require is the value of R3, correct? Now my question is mu 1, mu 2, mu 3, mu 4 and mu 5 parallelly arranged? Answer is yes. So if they are parallelly arranged, you can pick out any two mediums and you can apply Snell's law. How? So if you pick out this medium and this medium, because the arrangement is parallel, I can say mu 1 sine I1, it should be equal to, see, this is mu 3 sine R3, correct? Had the R5 or R4 or maybe mu 5 or mu 4 being not being parallel, then still it is valid. Yes, it is valid up to R3. If you do not arrange R4 or R5 parallelly, still it is valid in between 1 and 3, because in between 1 and 3 everything should remain parallel, right? So if in between 1 and 3 the arrangement is parallel, then from 1 to 3, starting from 1 up to 3, you can apply Snell's law. Here everything is parallel. So even you can write mu 1 sine I1 is equal to mu 5 sine R5. Even that is valid, because everything is parallel. So you can write mu1 sin I1 is equal to mu2 sin R2 is equal to mu3 sin R3 is equal to mu4 sin R4 is equal to mu5 sin R5. That is what I mean. But this property holds only in the parallel arrangement. Correct? Okay. What I say is this. In between 1 and 3, applying Snell's law. Okay. Now what you know? You know mu1 as 1. You know I1 as 45. So 1 sin 45 is equal to mu3. Mu3 is root 2 into R3 you have to figure out. If you look from there, sine R3 becomes 1 by 2. That means R3 becomes 30 degree, right? So in this problem, the answer for R3 is 30 degrees. Let's look into the options. Option A will be the correct option in this case. This is one of the best problems from this TPP. A very fundamental, logical, but simultaneously it involves the concept of vector, right? The components of vector. So you need to understand a little bit of vector analysis, right? And then if you apply the concepts of this chapter, which is geometrical optics, if you apply the concepts of this chapter and add it to some vector analysis, you will get the answer. So the statement is, the XZ plane separates two media, A and B, of refractive index 1.5 and 2 respectively. A ray of light travels from A to B in the direction in the two media are given by unit vectors UA cap as AI cap plus BJ cap and UB cap as CI cap plus DJ cap respectively. Then you have to figure out the correct relation out of the given four. Correct? Let me explain this problem first. This is an XY axis, the Cartesian coordinate system which is given to you, right? Now the Z axis will be this. Do you agree? So if you look into this plane, this is an XZ plane, right? See, A is the region above X and B is the region below X, right? So the two media, let's say, are A and B in such a way that they are being separated by XZ plane. Are they being separated by XZ plane? Yes, because X-axis is this and Z-axis is this. So at X-axis, if you take Z is equal to 0, Z is equal to 0, this, like this. Do you understand my point? This plane. Above X, there is one medium. Below X, there is another medium B. Basically, they are being separated by XZ plane, correct? But the unit vectors of the incident and refracted rays are given in terms of I cap and J cap. That means the ray is moving along X and Y, correct? So let's suppose the incident ray is this UA cap and the refracted ray is this UB cap, correct? Let's say it makes an incident angle I and refraction angle at the interface boundary, the refraction angle is R. Now you need to understand a little bit of vector analysis. See this. If some vector is given to you, let's suppose it is xi cap plus yj cap. Then, and let's suppose this is y-axis and this is x-axis. Right? Xi cap plus yj cap, I'll just change some notation because of this x and y are being used in coordinate axes. So let's say it is alpha I cap plus beta j cap. Correct? Then what alpha gives, what alpha represents? Alpha is the component of this vector onto x-axis and beta is the component of this vector onto y-axis. Correct? By the same logic, the unit vectors, if given, the first unit vector is UA cap. First of all, UA cap will have a net magnitude. Net magnitude is equal to 1 because it's a unit vector. UA cap is given to be AI cap plus BJ cap. So the first thing I will write is mod of UA cap is equal to 1. And the mod of vector is given by under root of its component square, summation of its component square. So that's A square plus B square. That's equal to 1. First thing. Okay. Then UA cap is like this, is shown like this. It will have an X component and Y component as well. This is AI cap plus BJ cap. That simply means this is B and this is A. You might say, sir, B is along J cap and this vector comes out along minus J cap. So why it is B? Then I will answer to this that B might be a negative quantity. It is not mentioned that B is a positive constant. So this might be the case, right? B might be negative, no restrictions over B. Correct? A is along positive x-axis, so A is positive only. Correct? Now, here I, if you see, I is the angle. Which angle? Angle made by this axis, this UA cap from the y-axis. This is I. So in this triangle, let's say alpha, beta, gamma. In the triangle alpha, beta, gamma, if I try to get sine I, what is sine I? Sine I is perpendicular, that's A, upon hypotenuse. What is hypotenuse? Under root A square plus B square, correct? Because this is B. This is small b, right? So under root A square plus B square. And what is under root A square plus B square? That's 1, right? So sine I will be equal to A. Equation number 1. Correct? Similarly, if we look onto UB cap, it is given to be CI cap plus DJ cap. Correct? Then that means its component along X is C and its component along Y is D. And this angle is R. Correct? So in this triangle, let's say alpha dash, beta dash and gamma. In this triangle, if you see, okay, not gamma, let's say this is O. Then in this triangle, if you see, sine R will be equal to perpendicular, that's this, and this is equal to C, right? This is the x component, this is equivalent to x component, right? So this is equal to C, perpendicular is equal to C upon hypotenuse, that's O beta dash. What is O beta dash? That this is C and this is D. So what is this? Under root C square plus D square, right? That's again equal to 1. So sine R is equal to 1. Sine R is equal to C. Sine R is equal to C by 1. So sine R is equal to C, right? Now, after saying this or after doing this, we apply Snell's law. Snell's law says mu A into sine I is equal to mu B into sine R. Do you agree with that? Yes, sir. Mu A is given to be 1.5 times sine I is given to is solved to be A, is equal to A by derivation, is equal to mu B is given to be 2 and sine R is given to be or is solved as C. So A by C comes out to be 2 by 1.5 and 2 by 1.5 is 4 by 3. So the correct relation in this picture will be A by C is equal to 4 by 3. Let's figure out some answer or some option is there or not like this. Okay, yes, there is. A by C as 4 by 3. Let's look at the options. Option A will be the correct option in this case.